For those of us who are coming here for the first time, this is a public forum for the city. It's designed not to be the anti-TED Talks. It is not, so it's supposed to be long lectures, Q&As, to allow people to reflect properly about the issues that are facing the human community, and not least of which is, of course, is a growth of cities and the impact they have on our civilization. So with that little preface, I want to introduce the speaker, Tim Wallace, who's a geographer and visual journalist at Descartes Labs in Santa Fe, New Mexico. I like the name of the lab. He has a PhD in geography from the University of Wisconsin-Madison and was recently a graphics editor at the New York Times, where he created visual stories on neighborhoods, cities, regions, and the world with information gathered from land, sky, and space. Tim does not live in Maine, from what I see here, but his parents and in-laws, whom I met, do. So there's hope. So help me welcome Tim Wallace.
Thank you so much. Thank you all for coming out tonight. It's an honor to be here, especially as an outsider and Mainer wannabe, in the midst of such an engaged and impassioned debate about community in the process of some real change. I'd like to thank Addie Smith-Ryman and the Portland Society for Architecture and UNE for inviting me and for hosting me. And I'd like to thank all of the Complete City Imagine Design Competition participants for their important and thoughtful work. If you haven't been to the exhibit yet, please do go. It's fascinating, inspiring, irreverent, absurd, and most of all, hopeful. It's hopeful because this city faces a whole host of challenges right now, but its citizens and lovers of Portland care so deeply about its future. Proposals and projects that have an impact on the quality of life here in the short and long term will not go unnoticed. So who is this guy who's standing up here who's some Mainer wannabe? My name's Tim Wallace. It's been said several times now. I was a graphic journalist at the New York Times for about 7 years, but I've had quite a journey to get through there and now to Descartes Labs where I work. One of the things that I did first was, as an undergrad, I wanted to be a maritime archaeologist. So that's me there learning how to scuba dive when I was in college. And I've always been interested in decoding the world around me, either through evidence of past cultures or digging through heaps of digital data to find a story. After undergrad and after grad school, I got a job in Rhode Island as an archaeologist where I had the pleasure of being featured here in this local newspaper. I like it that they call it a treasure trove, but if you read down in there, it's a rum distillery. And as you can see from the surroundings, there was no real treasure there. It was pretty stinky and dirty. So I did archaeology for a little while, and it was mostly desk-based work, and in the end, I was doing mostly mapping. So I was doing things like this with the Total Station. This was in Vermont at an abandoned copper mine. And the image on the right was my wife in my apartment in Brookline, Massachusetts at the time. I tested out that technology on our living room, which we called the lodge. And so, but I was doing all this mapping and all this modeling, and it wasn't enough. I felt like I needed to do better. So I went to grad school and I got my PhD in geography and cartography. And I got a job at the New York Times where I continued doing mapping, but no longer with a Total Station. Now I'm doing it with drones. So here I am on the bayou in Louisiana for this piece about a town south of, Jean Lafitte, a town south of New Orleans that is very much in danger of washing away. And here I am working on another story, this time in New York City. The cameraman in between me and Gabe Dance there was from The Fourth Estate, which was a show that aired on Showtime. They kind of followed a lot of people around. Most of the footage got cut, as you'd expect, but including this. This was not a part of the show. But here I am looking somewhat hopeful, and they're looking somewhat concerned because they'd never seen a drone take off from the bow of a ship. And I was just happy to get the thing in the air. And then after taking the footage, you can see I have the serious face on because I'm terrified I'm going to lose the footage, and they're happy because they know I got the shot, and they're not at all concerned about landing this tiny little drone on the bow of a ship or a boat so tiny you can't even really see it around us. Thankfully, I did not crash the drone, and we didn't use the footage in this piece on Trump's properties in New York and his family properties in New York. And that piece did end up going on to win a Pulitzer. I'm not taking credit for that, of course. I was just very happy to be a part of the project. So again, nowadays, I work mostly in digital dirt. I don't work with a shovel, and I don't dig up distilleries anymore. This is a piece that the Data Visualization Society published last week. It was a little interview with me. It was kind of fun to talk to a young data visualization enthusiast. And he came up with this tagline calling me a spatial data archaeologist, which I think makes sense. It kind of draws a thread from digging up distilleries to now trying to find stories in spatial data. And while I'm doing this, I desperately am always looking home to this home that is yet to be home, Maine. I live in Santa Fe, New Mexico. This is a map of the route that my family took to Maine this summer for a summer road trip. It's not your typical road trip 2 states down or over. It's across most of the country. You'll notice we somehow managed to avoid Massachusetts. I don't know if there was any regional rivalry here, but I suspect some people might enjoy that. So we do get back to Maine as often as possible, and I do, in fact, map it as often as I can. So that's a little on me. The complete city is not an island. I'm not an urban planner, but I do know that things do not exist in isolation. Neighborhoods have their local function, and together they make up the fabric of a city, which offers services and resources to the regions in which they sit. Waldo Tobler, a famous 20th century geographer, said in 1969, this is his first law of geography, everything is related to everything else, but near things are more related than distant things. So in that sense, neighborhoods are important because everything in them is closely related, and they are also related to cities, and yet also a little bit more distant, but still related to their regions. And you can see this on this map of the neighborhood we're in here. It sits nicely in the city of Portland. And you see the neighborhoods falling together to make up the city, and the city falling to make up the region. And the title of this talk is Sensed, Imagined, and Realized. And I realize that sensed is maybe the least straightforward of these words, so I thought I would take a moment to define it. I don't mean incensed or incensed. I mean sensed, as in something you see, something you hear, something you feel, the sense of the city around you, which can be done sort of inherently in the human way, just taking something in, or it can be done through devices or measurements. A qualitative sense of a city comes from Kevin Lynch's book from the 1960s, The Image of the City. This is an urban planning book. This is an interview taken from an old wrinkled woman, probably 90 years old, when they were asking people around the city how long it takes to get from Mass General Hospital to the public garden. She has her opinion. It's the way she senses the city. Kevin Lynch and his colleagues combined these things into composite images that made up a sort of collective look of Boston at the time. This is a composite orientation map. This I quite love. It's a sort of minimum maximum agreement map on where neighborhoods sit. And then there were some more contentious things, the subjective sensed city and the human context of the word, business and retail, where's the good housing, where's the prestige housing, where are the slums? Nowadays we have satellites. This is an animation of all of the satellites launched that we have record of anyway. I'm sure there are secret government ones that aren't a part of this record. Launched since the 1950s. And here they are cumulatively animated. That's a lot of digital eyes on our planet. Some of those satellites are very coarse resolution, but they take images very frequently. This is a Japanese satellite, Himawari. The US also has a GOES satellites 16 and 17 that take images as frequently as every minute for storm events like this. Then there are slightly higher resolution satellites like Landsat, which is a legacy United States government satellite, and Sentinel-2, which is a European Space Agency satellite. And these are, this neighborhood where we sit now, the last several hundred observations going back 3 years. This is another satellite. This is not an optical satellite. This is Sentinel-1, a radar satellite that can see through clouds and it can see at night. And as you can see clearly from this image, it detects elevation quite well. And we also have private companies that are pledging to take images of the entire Earth every day, like Planet Labs, and this Canadian company, Black Sky, which, if you read the fine print there, says that it will be, when all of its satellites are in orbit, it will be observing major cities between 40 and 70 times a day. This goes beyond the visible spectrum as well. ICE-I, a small-sat company, a European small-sat company, will be delivering radar imagery of everywhere on the planet daily. We have sensors on land, too, like this USGS webcam that was taking an image every 5 minutes during the 2018 Kilauea eruption. And then we have, again, the overhead reference for what that looked like. This is a Sentinel-2, a European Space Agency image. We have traffic cams and webcams and dashboard cams, some of which have artificial intelligence attached to them to categorize and process data in real time. This is a funny example I found on YouTube that for one of the people crossing the street, it changes from traveler or person to defender because she lifts her arm up very briefly. There's YouTube as well. This is a drone footage of the Donetsk airport in Ukraine after it was bombed, which you can use to create visualizations by processing and stitching together all the frames from the video to create a before and after image. We have sensors in our pockets, too, assuming we all have phones in our pockets. We might have other sensors, too. I guess we have sensors on our wrists. We have smart watches. This is an image taken from a New York Times piece on cell phone data. Sometimes when we agree to the terms of the company on an app that we install on our phone, they might be selling our locations to an aggregator. And there are a variety of things that can be done with that data. I'll have one fun example later. Some satellites are designed specifically to measure pollution. This is a global composite of NO2 emissions over the last year. And here is a up close on the Middle East of the maximum seen at any given time of NO2. You can see some funny spider patterns around cities, smaller cities especially, that stand out, which we're pretty sure are related to airplane emissions. Here's the Northeast for reference. Methane, which is one of the worst greenhouse gases by most measures, lasts about 10 years in the atmosphere and has a profound heating potential. It's also measured by the Sentinel-5P satellite put into orbit by the European Space Agency. And this composite shows some hot spots, including the Permian Basin, where there is potential leaking if flaring is not active. The Central Valley of California, which is related to farming and industrial cattle ranching. And also some natural sources like the Horicon Marsh in Wisconsin with marsh gas. As organic matter decomposes, it releases methane. Some of these satellites can be used to create derivative products that are also interesting and good to know about our cities. This is a composite that I made of urban heat islands in Massachusetts. I didn't go there on my road trip, but I did map it for this purpose. Here's Boston and the surrounding area showing the hottest areas in the region over the summers of 2017 and 2018. And here are a couple of examples showing some cold spots like Mount Greylock, the highest point in Massachusetts, and some hot spots like the mill towns of Springfield and Lowell. We can also be sensors ourselves, as in this case of the squirrel census in New York's Central Park. I like this from the Squirrel Census website. We counted them in October of 2018 with the help of 323 volunteer squirrel sighters. And we have Google Maps and Apple Maps and OpenStreetMap, which are keeping near constant track of everything that is going on. For example, right now, if you were to look up Innovation Hall, where we are right now, you would see the thing that is happening right now. It's not just a passive reference map anymore, it's a living, breathing copy of what's happening around us. So those are some ways that we sense the world around us. Let's talk about some things that are imagined. When I first started thinking about this talk, I thought about this very extreme example of urban planning, sort of experimental urban planning, if I may be so bold, that came to mind from grad school, this Buckminster Fuller and Shoji Sadao 1960 proposal to throw a dome over Midtown Manhattan. I'm sure some people in the audience know more about this than I do, but I do love the idea of imagining alternate realities like this and alternate futures. And if you go to the exhibit here, you will see a mixture of things that propose different futures for Portland. There are visionary things like this monumental scale ecology museum or in Back Cove. There are irreverent suggestions such as docking stations for pool toys during times of catastrophic flooding. And there are sweet and aspirational things like these hopes of children. More bikes, more compost, be kind, plant more trees. Use your apples. I'm not sure what that one means. I'm definitely going to use my apples, though. And there are things that suggest that in real time you should imagine a better future. For example, how do you fix the intersection at Woodford's Corner? DIY is sort of like a modest proposal or a moonshot. And a whole multitude of other suggestions and inspirations for a different future. Another way we digitally imagine things both in the past and in the future is through creating composite imagery. This is an image of Lexington, New York during peak fall foliage. It was about 2 weeks ago, maybe 3 weeks ago. You'll see there's a cloud there in the corner. This is pretty common during the autumn in some of the areas of the country with the most beautiful fall foliage. In fact, if you look at an image of the continental United States for every day during peak fall foliage, you kind of notice a trend of where all the clouds are. So when the Washington Post came to me and my colleague Krishna Kara and said, how do we map fall foliage? We weren't quite sure something like this was possible. Can we make something that represents only a few days of the year? How do we do that? And it turns out we could do that. This is a fall foliage progression using MODIS satellite data. And the way we got around the clouds was by creating a decadal composite using just images from certain days of the week. So each frame of this animation, as you see it, is a week of imagery across 10 years. And that's how we got rid of the clouds. And that is the sort of thing that we can do nowadays to imagine things that cannot be seen from above without help. Here's the Upper Peninsula using the same technique. By using this technique, too, we were able to discover some things regionally that we weren't aware of before. For example, the Upper Peninsula has a shorter peak season. It only lasts a few days, whereas New England kind of takes its time, which is probably why it's quite famous and has all those weekends with regional travelers coming to leaf peep. Another way that we're imagining, at least at Descartes Labs right now, is doing something that we've been calling generative geographies. And what I mean by that is we're abstracting geographies to the essence of what those places are. For example, here is a city park. This is a random city park. I believe it's somewhere in the Southwest. And we thought, hey, could we train an algorithm to recreate a city park if we gave it enough training data? So we fed this algorithm tens of thousands of images of city parks like this and of city parks in cities like Portland, Boston, New York, all over the country. The only guideline we gave the algorithm was the size and orientation of the park and how much of the image it takes up. The result was not so great. I'm not sure if you showed this to anyone, they would think city park. They might think computer glitch, maybe petri dish. We've done this with a few different kinds of geographies. This one, I'd prompt you to guess, but that would probably just be embarrassing for me. This one is based on New England islands, including many, in fact, probably most, were islands in Maine. This is another experiment we did with more southerly islands, like the Caribbean and Hawaii, and so on, tropical islands. And this, which is probably perhaps more relevant to this discussion, this is an image of Manhattan-ness. I think if you just glimpse at this briefly, you might, at least if you know Manhattan well, you might think it's an image of Manhattan. This is also an image of Manhattan-ness, as is this. And you can tell the algorithm picks up the idea of the orientation of the roads, which is very true to the Manhattan grid. And also, we believe that it's picking up roughly the percentage of tree cover in the city. This is an actual image of Manhattan, 100% Manhattan-ness. On a global scale, we've also tested this out with full disk images, as they call them. They're images that capture an entire hemisphere. These are some attempts at recreating Earth. And this is the algorithm as it goes from the most principal component, the most common element, to some of the more detailed elements of Earth. You see it starts out with both water and the glint in the middle of the globe. That is because the images that we use to train the algorithm are located right between the Earth and the sun, so it always has the sun glint right there in the middle. Over time, it picks up clouds, and it starts to pick up continents as well. Here are some of the more successful examples that we found. So these generative geographies, why bother, right? This doesn't seem like it's super useful. But believe me, there is more to it than artistic experimentation and wackiness off the rails. This is a quick animation of California's Camp Fire from last year. The time from ignition to devastation was tragically short. What if we could detect it and alert people faster? My company, Descartes Labs, is building a fire detector that could alert local officials to a potential fire within 5 minutes of ignition. And the way that is being done is by experimenting with a machine learning algorithm to look at recent images in order to predict what the next one will look like. When the prediction is compared to the next real image and a hot temperature anomalies exist between the two images, there's likely a presence of the fire. This is something that is in development. Currently, there is a fire detector that we have built, but it does not yet use machine learning. We do think that machine learning will fine-tune this detector, though. Even without machine learning, this early version of this feed has been successful. The LA Times is using it, and we were able to spot and deliver data on the Kincaid fire to the LA Times before local authorities were able to map it and get information out to media. Let's do some journeys through sensed, imagined, and realized. If there are any geographers in the audience, they're probably like groaning to themselves right now, using cholera in 1855 as an example of mapping. This is the example of early GIS. John Smith mapped cholera around London using little dashed lines on the map, and also mapped where water pumps were. And he discovered that there was a pattern. So in his book, he says that he had an interview with the Board of Guardians at St. James Parish on the evening of the 7th of September. And he represented the above circumstances to them, this map. In consequence, the handle of the pump was removed on the following day. And so, what was realized after that? On September the 8th, the day the handle of the pump was removed, there were 12 attacks of cholera. On the 9th, there were 11, on the 10th, 5, on the 11th, 5, and on the 12th, only 1. And after that, there were never more than 4 on a day. Now, Snow himself wasn't entirely certain that the pump handle removal was the only thing that caused this dwindling of cases. In fact, people had already started to leave the neighborhood, so that would certainly come into play. But in any case, this played a major role in early mapping in terms of sensing something, imagining how you could have a different future, and then realizing it. Let's do a little bit more uncomfortable example. Sensed, imagined, and realized from politics now. Here are the raw vote count margin results of the 2016 election. This is a project I worked on when I was at the Times. The first thing that jumps out to me, and perhaps to others, are the clusters of big blue dots and a wave of red across the rest of the country. So at the time, I imagined a different sort of map, a different way to visualize this. Here's my mom's hand right there. You can meet her in person afterwards if you want. She's in the audience. Holding up this map that I made against a Rand McNally reference map. And what I did was I basically cut the two results into two different maps. I calculated what I called a zero vote margin line. I used those dots to interpolate a surface between voters. This was the result for Clinton's America. This was the result for Trump's America. Unsurprisingly, voters for both candidates enjoyed these maps for different reasons. Now, how do we realize this? Do we want to realize this? I don't think we want to realize this. Do we really want a country cut up into pieces of Swiss cheese and bits of Jell-O left on a kid's plate? Well, let's hope not. And that is sort of segues into sense and imagined and realize isn't always a good thing. This is another project that I worked on at the Times on Hurricane Harvey. I believe I was actually sitting on my in-laws' couch when Hurricane Harvey at the end of August 2017 hit the coast of Texas. And my boss called and said, hey, can you go cover this thing? And of course I said, do I have to? I was on vacation in Maine. But I went. And as a part of reporting this piece, I ended up at the National Archives in Fort Worth. And I wanted to understand the urban landscape there and how a flood like that could be possible. And I found this note from a concerned citizen to the Army Corps in the early 1940s. It was undated, but it was in a folder from the early 40s. And I love this line where he says, I wonder if the government has decided to make some sort of flood control survey. The papers say that the city is going to try and have one made. What have we been doing all these months? Just out on a picnic, I suppose? The bayou is on a rampage, and he goes on to talk about how it's at 7 feet where it should be 1 foot, and on, and he signs it best regards, Cecil Burson. So this is something that had been sensed in Texas, and it had been imagined. In fact, in the 1950s, the USGS government-issued map showed the Barker Dam that was built there and reservoir as something that was subject to inundation. Years later, in the 70s, it was still subject to inundation. In the 90s, those dashed lines mean land subject to inundation. And so you have this progression where the institutional legacy, the knowledge that the government has is that this area will flood. But the last map, which is from this year, shows clearly that there is a neighborhood built directly inside this area that was subject to inundation. So here's an animation that goes from 1984 through just a couple of years ago, showing how this happened as Houston was growing. It had, in some cases, nowhere to go but into a reservoir. And so what did this look like when it was realized? Well, when Harvey hit, over many areas of Houston got more than 40 inches of rain, resulting in catastrophic flooding throughout the area. And there's a little dot there on this map for Canyon Gate, this neighborhood, that looked like this, completely flooded. And like this. It does make you wonder if the things that had been sensed and imagined had been realized differently and plans had been done differently, if some of this could have been avoided. Here's a more regional example of Nantucket from 2018. It's a study on Nantucket of using mixed data sources, the cell phone data, ferry, ridership, and so on, to try to determine how many people actually live there year-round. It's a famous tourist destination. There are several more thousand people there, undeniably, every summer than there are during the winter months. So an agency came up with this novel way to map it using cell phone data. And they discovered, using this method, that they believed there were about 6,000 more people there year-round than previously thought. So what will be realized from this? Why bother with this? Well, as it turns out, like the rest of the country, Nantucket has a vested interest in complete head count, not just representation, but there is a lot of federal money being allocated based on population. And at a local level, you want to have those services that are commensurate with the number of people you have living in your town. Let's take a look at Portland. That's where we are right now anyway. This is what this is all about. Maine is heat resistant. I know it doesn't seem that way, especially in August, but this 2016 Climate Central study, which was something I made maps for at the Times a few years ago, shows that every year from 1991 to 2010, there were this number of days above 100. Apparently it averaged less than 6, certainly in Maine over those years, and will still in 2060. And most of the state, anyway, still will not be as hot as the rest of the country by 2100. But there are things that make a place hot, and one of them is cities, urban structures, the built environment. So let's take a look at trees. Here is Portland, and on the right we have the peninsula and its leafy areas. Here's the West End, which unsurprisingly has a pretty healthy tree canopy. And Munjoy Hill, and the Eastern Promenade there with a pretty big stand of trees. And then where we are here in Deering Junction. We have Evergreen Cemetery, which has lots of trees, and then we have University Park over there. And we're right here, right under the pointer finger. What do we imagine, though, can happen here? What might surprise us? Well, while looking at these maps, I stumbled on this article about how this park has been proposed, is part of a proposal for 40 new homes. And it's become a contentious situation. I'm sure many of you in the room know about this. It's a beautiful park. My parents and I drove by it on the way over here because I was just extremely curious. It's a big park. You can tell even from this map, it constitutes a quite a large area of greenery. And if you look at it on another kind of map, you can see how it might be important in another way. This is a map of heat. If you remember the map of the Massachusetts urban heat islands that I showed earlier, this is that same data set. The colors here, red, indicate heat, and the pixel just below the C and N is the hottest pixel in the city. It represents a day at some point during the summers of 2017 or 2018, where the max temperature reached 111 degrees or thereabout, with caveats. Of course, this is processed data. So this is an urban heat island that exists right where this Reed Street self-storage building exists. And it certainly has something to do with the building and also the pavement, the parking, and the adjacent buildings. But again, it's the hottest that was registered. So this is the whole city, and we have the Sappy Paper Mill. We have the neighborhood here, Deering Junction, and you see that the Hannaford Distribution Center, a Coke facility, Main Mall, and you can see that the city is hot. It has its heat islands, but Deering Junction, this one spot, still really stands out as a hot spot. So what will be realized here? What will become of this green space? It's 1,200 feet away from the proposed 40 home, or it's 1,200 feet away. The green space where the 40 homes would go is 1,200 feet away from this urban heat island. I can't say for sure, but it does seem like that would impact the heat island and perhaps make it bigger. And while Maine is heat resistant, there's no telling what's next here. So this is one way we can look at kind of all of the things, all the things that we can sense and try to process them to figure out what to do next. This brings us to the competition. I was so inspired by what I saw in the exhibit, and so it's hard to just distill it down to the winners, but I will briefly show them anyway because they deserve the acknowledgement. Portland's Urban Ballet, a socially conscious placemaking prototype. I love this. It breaks up the city and makes local issues addressable locally. Neighborhood scale shelters, which can be integrated into neighborhood context, address medical and commercial needs, and attainable housing, retail space. It's a careful, contextually sensitive plan, and here are a couple of images from it. This is taking a well-known lot and imagining it in a much more functional future. We have smart scales, allocation strategies. This is an interesting proposal for a real-time interaction system with solar petal trees that do all kinds of things like collect air quality and transit information, provide city amenity information, and produce energy. Sort of a smart city plan influenced by models in Amsterdam, Copenhagen, Melbourne, Singapore, and Tallinn. These are really beautiful plans, very inspiring. And finally, Forest City of Birds and Birdsong, making Portland a city where every resident and visitor can enjoy the sights and sounds of nature. That sounds pretty spectacular, doesn't it? But what will be realized here? We've always imagined, but we have an unprecedented amount of data sensed about our cities and an ever-increasing amount of methods for processing and distilling it. What we've seen here, what contestants have drawn from inspiration to the community and the clear love of their home, This has all been sensed. This has been imagined. But what will we realize? The challenge ahead of us, sorry, you, I only wish I lived here. The challenge ahead of you is to make the most of the data at your fingertips and the most of your imaginations so that one day you can realize a better Portland, one that is climate resistant, attainable, healthy, culturally vibrant, and ready for whatever comes next. Thank you.